out as infinity, and that was 0, then when you drop this, 1 over infinity will become 0. So you get 0 over 0. You don't have to verify it, but you can if you want. I decided not to. I might go back and I have to pull it out. It's going to suck because when I take the derivative, I'm going to have to use chain rule here. And with that 2 there, I have to pay attention to that with chain rule. If I had pulled it out, it would be a constant that would come for the ride. So I'm going to do it without and see how it goes. All right, we good? Ready? L'Hopital. Natural log y equals, by L'Hopital's rule, limit x goes to pi over 2 from the right, from the left. Okay, derivative of natural log of something is 1 over that something, right? Derivative of natural log of something is 1 over that something times the derivative of what's inside. But this is sine squared x, right? So the first thing that has to happen is the 2 has to come out in front of the sine, right? So that's the derivative of 2 to sine of x squared. You bring the 2 out, sine to the first power. What do I still need here? Cosine x. That's the derivative of the sine itself. So that's the derivative of the numerator. All over, okay, what's the derivative of cotangent x? Negative cosecant squared x. Negative cosecant squared x. And that's off your formula sheets. I showed you last class that, as good as L'Hopital's rule it is, remember I said it's not the magic pill, right? So it might turn out that this is not going to get better. Let's just keep going. Natural log y equals limit as x goes to pi over 2 from the left. Okay, what can I do up top? One of these signs cancels, right? So do you all agree that the top is 2 cosine x over sine x? Right? That's the 2 and the cosine together. I slide it on top of that sine. And isn't the bottom really just negative 1 over sine squared x? Isn't that what cosecant is? Cosecant is 1 over sine. And so I have 1 over sine squared, and then there's a negative out in front. So I just put the negative up top. Do y'all agree? Now I have a fraction over a fraction, so I can flip this fraction up. Let me go ahead and do that right here. Flip this up. Sine squared goes on top, and on the bottom I have negative 1. Things are looking pretty damn good here. Like things are starting to cancel. Let's see. One of these signs. Oh, God. Got that, right? Still good? So what am I left with? Let's see, limit. Yeah, natural log y equals limit. Let's see, x goes to pi over 2 from the left. I have a 2 and a negative 1 here, right? 2 and a negative 1. So I'm going to just put that out front. Negative 2 times, I have a cosine x, and I have a sine x. That's all I have, right? I want to know what happens as x goes to pi over 2 right here. I don't have division by 0 anymore, do I? I don't have anything bad happening. What is cosine of pi over 2? X coordinate at pi over 2 is 0, right? So this is headed to 0. And sine of pi over 2 is 1. So we have negative 2 times 0 times 1, which is just 0. So the natural log of y is 0, which means e to the natural log y equals e to the 0. Isn't that exactly what we got last time? So this is y is 1. The answer is not always 1, okay? If it was, I would just tell you that in the beginning, all right? Just so happens that it's 1 this time. Okay. There are 3 ugly forms, 1 to the infinity, 0 to the infinity, infinity to the 0. Those are the 3 bad ones. If we see that, we call that limit y. We take natural log on both sides. We pop the thing that's in the exponent out front. Then we drop 1, and we do L'Hopital, and then we hope for the best, right? That's the plan. Okay, I'm now going to show you the one that's like the classic example. Like every Cal 1 student has to see this example, all right? limit x goes to infinity of 1 plus 1 over x raised to the x. You'll see why this is a classic example when we get to the end of it. Do y'all understand why on an exam I'm never going to give you this as a limit on the exam? I'm never going to give this to you. I'm always going to give you one of these, because to do one of those you have to be able to do this, right? Because to do that you have to be able to convert it over to this and then drop one down. So you'll never see one like this alone on a test. There'll always be something like that. All right, so let's see. If x goes to infinity, let's see what's happening here. 1 over infinity goes where? 0. 1 plus 0 goes to 1, right? So this in here goes to 1, and the exponent goes to infinity. That's an indeterminate form, right? This looks like 1 to the infinity. Natural log, right? Call it y first, and then bring the natural log in. So I'm going to call this thing y. Let's call it y. So here's what I've got. Natural log y equals limit x goes to infinity. I'm going to go a little slower this time. Natural log 1 plus 1 over x raised to the x. On this one, I brought the natural log on both sides, and I just pushed the natural log past the limit, but I didn't drop the x out yet. Just going a little slower on this one. Now I will drop the x. So this x is going to pop in front here. So natural log y. Isn't that a really nice property of natural log to be able to do that? I mean, we use it a lot, so. Okay, there we go. It's dropped out front. Now, what? Drop the x. Yeah, let's not drop this, right? This looks nasty. Drop the x to the bottom as a 1 over x. Natural log y equals limit x goes to infinity of, let's say we drop the x, so we still have natural log of 1 plus 1 over x, and then over the 1 over x we dropped. Any questions there?
Well, what's helping not to use product rule?
The fact that you're not taking a derivative,
In the first place.
right? I'm not asking you to find the derivative of something. I'm asking you to evaluate a limit. And so when you evaluate the limit, you need to see what form you have. And the form you have is infinity times 0. And when you have that, you drop 1 and use L'Hopital.
How would you word the question on an exam?
Evaluate the limit. I would just put this up right here. I would say, find this limit, or evaluate this limit, right? That's different if I were to give you this and ask you to find y prime. That's last week, right? Or maybe the week before. This is logarithmic differentiation. I give you a function. Do you see a limit anywhere here? Right? There's no limit here. I give you a function, ask you for its derivative. You're here, you can do natural log on both sides. You're going to drop the x, but then you're going to do the derivative, which will be a product rule and things like that. Okay, so that's very different than what we're doing here. But I understand it's confusing. That's why I want to make sure you see the difference between the two. Okay, now over here. I dropped it, L'Hopital, right? Okay, take the derivative on top, take the derivative on the bottom. All right, so the top's a little ugly, but it's not that bad. The derivative of natural log of anything is just 1 over that, right? So 1 over 1 plus 1 over x times. Now you have to take derivative of what was inside. So what's the derivative of what was inside? Yeah, derivative of that's 0, right? Plus derivative of that, this is now what, the 4th time we've done this? Negative 1 over x squared. That's derivative of the inside. All of this over, now the derivative of the bottom. It's now the 5th time we've done this, right? Negative 1 over x squared. Y'all see it? They cancel, right? Now what we're going to do is we're going to take this limit, right? We take the limit, we're going to let x go to infinity, and what we're doing the limit of is this right here. 1 over 1 plus 1 over x. And when you do this, 1 over x goes to 0, right? That goes to 0, But you have 1 plus 0, so the bottom's 1, the top's 1. So you just get 1, right? Just get 1. But that's not the same answer we've been getting, right? Over here when we did this limit, what did we get? This limit was 0, right? So we had natural log of y equals 0. Here we have natural log of y equals 1. This is the first time this has happened. So this becomes natural log of y equals 1. And now to get rid of it, right, you do e to the natural log of y equals e to the 1. That means y is what? E. That's e. What? So this is e. That's what e is. It's this limit. So I think we were talking about this the other class. Okay? This is actually the definition of what E is. This is why this is a classic example. If you wanted to tell someone, hey, what's E, right? You could define it that way if you wanted to. Let me try and explain what I'm trying to explain. If I were to ask you right now to explain to someone what pi is, okay? Explain to me what pi is. Well, you would say, take any circle, okay? Take any circle, take its circumference, measure the distance around it, and then divide that by the diameter, the distance from here across to here, right? That's d, right? Circumference is the distance around it. The ratio, this ratio, that number divided by that number is pi. That's what pi is. Do y'all believe that? Circumference by definition is 2 pi r. That's the definition of circumference. And twice the radius is the diameter, right? Twice the radius is diameter. So this is really the same as d pi. And if you divide both sides by d, you get this formula right here, right? But this is it. This is the formula for pi. If you want to know what pi is, take any circle's circumference, divide it by its diameter, and that's what pi is. All right? What's e then? Right? Because we know pi is about 3.1415, blah, 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 right? Goes forever, irrational number. Okay, but what's e? Well, e is about 2.718. This is the actual definition of e. This is one of them. There's many definitions. But you could define it this way. You could define it as the limit of this function. So the way I like to think about this is, give me a number x and plug it in here. So let's start with x's. Let's just go with 2. If I plug 2 in here, I get 1 plus 1 over 2, and I raise that to the 2, right? That's if I plug 2 into this. What's 1 plus a half? Well, that's 3 halves, right? But then squared. And if I square that, I get 9 fourths. And 9 fourths is 2.25. All right? What's E approximately? Do y'all know what E is approximately? 2.718 something. Okay, so if I plug in 2, I get a number that's not very close to E, right? I mean, but it's at least it's 2 point something, right? E is also 2 point something. So what I would need to do now is get a bigger number. So let me go with 10. If I go with 1 plus 1 over 10, I raise that to the 10th power. If I were to do that on my calculator, I would get a number that would be bigger than this, closer to 2.718. I did not bring my calculator. You know what? I can have the computer do it. Let's have the computer do it for us. I'm curious. Okay, so I'm going to call m, I'm going to make it equal to 1 plus 1 over k raised to the k. Where's my slider? Why is it not giving me a slider? T, there we go. T, okay. Oh, I got to trick this thing sometimes. There we go. K, let's go step by 1. Let's let it go from 1 to, let's let it go to like 10,000. Hang tight. Okay, completely ignore, God, you can't even see that number very good, can you? Well, this number, do y'all see it, 2 right there? It's here and here. Let me make maybe I zoom in on the screen. There we go. Okay. So now what I can do is I can start controlling what k is. Now, k is actually this number x, all right? So I'm going to control this right here. I'm going to make it bigger and bigger and bigger, and we're going to see where this number goes to. So just pay attention to that red number. So we said if k was 2, oh shit, that grew way too fast. Let me do k is 2. Let me start at k is 2, just so you believe me. See, at k is 2 is 2.25. I think this is going to be too fast. Yeah, let's do 1,000. K is 2. Oh, there's 10. Look at that, 2.59. Let me keep going. 2.7, 2.717, 2.71, right? And I keep going and going and going, and see how it's getting closer and closer and closer to 2.718 something? If I go out to 2.718, notice that the first 3 decimal places are no longer changing. Actually, the first 4 decimal points. I'm causing some issues there. Look at that. So the further I go out, the closer and closer I get to E. But remember, E is a non-terminating, non-repeating decimal. So even if you were to get your calculator out and put what E is, it's going to give you some number like that, right? And if you want more decimals, you just have to go further out. That make sense to you? All right, so that's a classic example because your answer is E, and then that's therefore the definition. You could define E this way. All right, let's do another one. How are we doing on time? 9:50. Yeah. You want me to give you one to try, or you want to try one on your own? Yeah? You want to try one? Yeah? Okay. Let's see here. Little disclaimer, I have not worked these out, so I have no idea how bad this is going to be. It could turn out to be easy. It could turn out to be a catastrophe. All right? There we go. All right, I'll give you some time. One minus cosine x, cosine of 0, you gotta know what that is. All right, I think you can figure that out. Always make sure you have a problem, right? Always make sure you have a problem. Don't just assume that you're gonna call that y and do natural log on both sides. Make sure it's an indeterminate form. Especially because I'm pulling this problem from a book. They could be trying to make you work hard when you never had to. Those are the indeterminate forms. I'll be back. See if you're getting the same thing. Okay. You'll get to this? Which one did you drop? Okay. So you have to write as 1 over 1 minus cosine x, right? All right. That means you're going to have to do a quotient rule. You can't take derivative of those individually. You did natural log on the bottom? That might be better. It might actually be better. Let's see. This right here, I'm hesitant to want to do this, but I'm going to do it, okay? I'm going to try this. So if I do L'Hopital now, okay, I'm going to leave the natural log x on the bottom. Did it work out when you did it that way? Or are you stuck? Yeah? Okay, so if I do this, I have to do quotient. So I have to do derivative of the top, which is 0 times the bottom, right? Minus the derivative of the bottom. Be careful, what's the derivative of the bottom? Sine. Just sine x. Because derivative of 1 is 0, right? And then derivative of negative cosine x is positive cosine x, because you get a double negative there, right? Yeah. Okay. That's not who I was talking about. It's not that class. It's someone else. So this is going to be minus what? Minus sine x. Okay. Over the bottom square. Shit. This is not looking good. Hold on. I never took derivative of the top, did I? Wait a minute. Hold on. I was supposed to do L'Hopital. I was supposed to do derivative of the top. No one caught me on that. 1 over x, sorry. So derivative of the top is 1 over x over the derivative of the bottom, which is this, which is... we did quotient rule. We're just doing quotient rule on this. So derivative of the top times the bottom minus derivative of the bottom, right? Times the top. Top is a 1, though. I'll put the 1 there, times 1. Okay. And then over the bottom squared. This, like I told you, I just pulled this out of a book, so I didn't know if this one was going to be ugly or not. But are we okay up to this point?
Isn't that an identity? 1 minus cosine x squared?
The squared is not on the cosine. You'd have to square the whole thing and FOIL it out.
Okay.
Let's just see where this goes, okay? I'm not sure where this is headed. This is a good problem. Natural log y equals, okay, limit x goes to 0. All right, here I have 1 over x on top. On the bottom, this doesn't matter, right? 0 times that's gone. This right here is just minus sine x over, now this is kind of ugly, 1 minus cosine x, that quantity squared. Can't I flip this? I can flip this. Natural log y equals limit x goes to 0. Okay, I'm going to write that as 1 over x times, flipping that over is 1 minus cosine x, that quantity squared, over sine x. Negative sine x, thank you. Negative sine x. I'll just clean it up. One more line. Natural log y equals limit x goes to 0. On the top, I have 1 minus cosine x, that quantity squared, all over x, negative x times sine x. So I just put those two together, right? This is multiplication, so you're multiplying these two, which gives you this. Plug in 0 for x. Cosine of 0 is 1. 1 minus 1 is 0. Shit. Okay, 0 here, 0 times 0. Sine of 0 is 0. 0 times 0 is 0. You have 0 over 0. It's still bad. So you would have to use L'Hopital again. I don't feel like using L'Hopital again because I'm afraid where this is going, right? Yeah, you all agree? So let me back up then. We dropped this, didn't we?
Yeah.
Let's drop this one instead.
Sounds like a good idea.
Okay, so I'm going to go back to this step right here. When we were right here, I'm going to go back to this. I'm going to leave that on the board because I might wind up back there. I'm not sure. I like this problem. It's not straightforward. What?
Turning the screw.
Yeah, turning the screws. Yeah, not me. I heard that the other day. I heard it on TV. I think it was during a baseball game. I don't know. I think one of the announcers said it, and I was like, "See, I'm not crazy." Yeah, it was. Oh wait, hold on. It was a serial killer documentary. That's what it was. Sorry. Okay. This time I'm gonna leave the 1 minus cosine x on top, and I'm gonna put the natural log x. 1 over natural log of x on the bottom. I don't want to have to do that, but I'm going to. Natural log y equals limit x goes to 0, right? Derivative of the top, L'Hopital. Derivative of the top is just sine x. Well, that's good, right? If there's anything good, that's good. Derivative of top is just sine x. Are we okay with that? All right, the bottom is a quotient rule. You have to do quotient here. So derivative of the top, 0 times the bottom, minus the derivative of the bottom, 1 over x, times the top, all over the bottom squared. Y'all see the quotient rule there? That's quotient on this. The biggest mistake I see students trying this is they'll tell me that the derivative of that is 1 over x. Right? That's not right. Okay, this goes away. That's just negative 1 over x and then over that. I'm just going to have to do it over, well, I'll try it here. Natural log y equals limit x goes to 0. I have sine x on top. Then I have on the bottom negative 1 over x. And then below that, whoa, this is weird, natural log of x, but that's squared. This is like a very complex fraction. You got this over this fraction, but in this fraction you've got that fraction, right?
Yeah, I hate it.
You hate it. All right. Well, we keep going. I'm going to do it right here. So I have natural log y. There's all these different ways that I can do this to clean it up. I'm going to eventually hope that something cancels. How do I want to do this? Sine x, I'm going to leave that there, times, I'm going to take this and flip it over and put it next to sine. So I'll have natural log x there squared, and then below that I have 1 over x, but negative, right? Geez, I don't see this is any better than this. You could bring it all up. Let's see. Does that work? No, because we're still going to have natural log of 0, which is going to be negative infinity. But we could try it. Let's just natural log y equals limit x goes to 0. We have sine x times natural log of x, that quantity squared, times negative x. So all I did here was just flip this up. Okay, this flipped up as x over negative 1. So I have sine x times that, and that's this right here. And that did not save us, because when we let x go to 0, this goes to 0, sine of 0 is 0, that goes to 0, so these two go to 0, but that, natural log of 0, goes to negative infinity. So you still have 0 times infinity, which means you have to drop 1 and start to play this again. So I don't think there's any way at all that we are getting around having to do L'Hopital more than once. It's just a question, do you want to do L'Hopital on this, or do you want to do L'Hopital over here? This one? That, you like that one?
I mean, this one's already has like a top and bottom.
Yeah, this one already has, like, we're ready to go here, right? Let's continue this one. I'll go back to that one if I feel like it. This is a really good problem because this shows you, like, the thinking through this, right? It's not just as straightforward as all these other ones have been. So natural log y equals limit x goes to 0. Okay, I'm doing L'Hopital on this. So I'm going to do derivative of the top. That's a chain rule. 2 needs to come out. 1 minus cosine x to the first power times derivative of what's in here. We've done that 3 times now. That's just sine x over. Any questions on that derivative up top? On the bottom, product rule. See the product right there? Between those two. So I'm going to do derivative of this times this plus derivative of this times this. So derivative of that is -1 times sine x plus, now the derivative of sine x, which is cosine x, times -x. So times that one. Wow.